All right, so welcome to this video. We are going to be looking at vectors and some basic concepts concerning vectors. So we're going to define what a unit vector is, and then we're going to learn how to find the magnitude of a vector, how to add them, how to subtract them, how to find the resultant vector, as well as how to find the dot product of two vectors. Okay, so that's what we're going to cover in this video. So let's start from the definition there. So the definition there says define a unit vector. Okay, define a unit vector. So by definition, we are going to say a unit vector is a vector that has a magnitude of 1. Okay, so just simply write a vector that has a magnitude of 1. Okay, so that's a unit vector. So how do you find this unit vector? Let's say, for example, you are given vector A. So to find the unit vector is represented by A, and then hat is equals to the vector that you have divided by its magnitude. So this vector A divided by its magnitude like that gives you the unit vector. Okay, so that's the definition. We look at B. B, they're saying three forces that acts on a particle are given by, this is the force 1, force 2, and then force 3. Okay, so now before we solve any questions there, okay, I need to tell you guys about the vector notation. So for example, if I have my vector A is equals to, let's say 5i, okay, minus 2j, and then plus 3k. Okay, so this here, the vector notation here, I can write this vector in another way. So the other way is that I'll just write those types of bracket like that. And then here from the vectors, I'm just going to get the coefficient. So I'm just going to get 5, comma, minus 2, comma, what? 3. So this here, this notation is the same as this notation that I have on top. Okay, so most of the vectors, we're going to be dealing with them in this notation because it's easier. Okay, but if you want, you can still use the 5i minus 2j plus 3k. So what I've written here is the same as 5i minus 2j plus 3k. Okay, so the notation is the same. So I'm going to be using this notation here in solving most of these questions. So let's look at the first question here. So the first question, they are telling us to find the magnitude of F1 and F3. Okay, so F1 is equals to, I'll write it in this form. The coefficient of I is 20. The coefficient of J is minus 3. The coefficient of K is 73. Okay, so to find the magnitude of this vector here, of this force, we're just going to say we square each and every coefficient that we have here, okay, and then we add and then we take the square root. So that would be the square root of 20 squared plus minus 3 squared plus 73 squared. So what I get is 20 squared, that would be 400, plus minus 3 squared, that will be 9, and then 73 squared, that will be plus 5,329. So I'm just going to add everything that I have under the root. So 5,329 plus 400 plus 9. So that is going to give me 5738. And then I take the square root. So I'm getting 75.7 4958. The number still goes, so I'm just going to round it off to 2 decimal places. So that will be 75.75 Newton. Okay, so that will be my magnitude of vector F1. What about the magnitude of vector 3? So look at vector 3. So vector 3, F3 has been given as just minus 12k. So it means that the I and the j components are 0. So this will be the same as 0, 0, and then minus 12. So to find the magnitude of F3, we're just going to say 0 squared plus 0 squared plus minus 12 squared, and then square root. So 0 squared is 0. Okay, so minus 12 squared, we're just going to get the square root of 144. So the square root of 144 is still 12 newtons. Okay, so the magnitude of F3 is 12 newtons. Okay, let's look at part D. So part D, they're saying find the resultant vector. Okay, in fact, it's find the magnitude of the resultant vector. Okay, find the magnitude of the resultant vector. So the resultant vector is going to be gotten by finding first, okay, the sum of all the vectors that you've been given. That's the resultant. So I'm going to say the resultant vector is equals to F1, okay, plus F2 plus F3. So this is what gives me the magnitude vector. I mean the resultant vector. So it's just going to be equals to, so this guy here is simply 20 minus 3 and then 73 plus F2 is minus 17. Okay, so there's minus 17 there, and then 21, then minus 46, then plus the vector F3, it's 0, 0, minus 12. Okay, so we always add the vectors by components or component-wise. So meaning the I adds to the I, the J to the J, the K to the K to the K. Okay, so that would be 20 plus minus 17 plus 0. That will simply give me a 3. Then minus 3 plus 21 plus 0, that will give me 18. 73 plus minus 46 plus minus 12, that will give me positive 15. Okay, so meaning that the resultant vector, it's simply 3i plus 18j and then plus 15k. Okay, and remember that this is what? Newtons. So this is the resultant vector, okay? And then if we want to find its magnitude, we're just going to say magnitude of the resultant is going to be equals to 3 squared plus 18 squared plus 15 squared, and then we take the square root. So this will be equals to, okay, so I have 3 squared plus 18 squared plus 15 squared. So all that gives me a 558. Then I take the square root of that. I'm just going to get 23.62. Yeah, 23.62 newtons. Okay, so that is the magnitude there of the resultant vector. Okay, so first we found the resultant vector and then we find its magnitude. All right, next we'll be finding the magnitude of F1 minus F2 and F2 plus F3. Okay, so let's do that. So first of all, we need the answer to F1 minus F2. So F1 minus F2, this will be equals to the F1, it's 20 minus 3, 73, minus the F2 is minus 17, and then 21, and then minus 43. So we subtract just like we add, component-wise. So it will be 20 minus negative 17. So that is just going to give me 37, comma, minus 3 minus 21. So that will be minus 24. And then 73 minus 43. So this negative and that negative becomes a plus. So it becomes 73 plus 46. Okay, so 73 plus 46, that gives me 119 like this. Okay, so this one here is the vector F1 minus F2. But now we have to find the magnitude. So it will be the magnitude of F1 minus F2 going to be equals to the square root of 37 squared plus minus 24 squared plus 119 squared. Okay, so that's what we have. So on my calculator, 37 squared plus minus 24 squared plus 119 squared. So that is going to give me the square root of 16,106. Okay, so we take the square root of this guy. I'm going to get 126.91. Okay, so that will be newtons. So this here, that's the magnitude, okay, of F1 minus F2. So I've just rounded off to 2 decimal places. Let's find the magnitude of F2 plus F3. So F2 plus F3, this is what we have here. So now F2 is minus 17, 21, then minus 46. Then I'll say plus the F3 here only has a K. So it means the I is 0, the J is 0, and then I have minus K. So this will be minus 17 plus 0. I get minus 17. 21 plus 0, I get 21. Minus 46 plus minus 12, that will be 58 somewhere there. So that will be minus 58, right? Yeah, so that will be minus 58. And then now I find the magnitude of this. So the magnitude will be minus 17 squared plus 21 squared plus minus 58 squared. So punch this on your calculator. So I have minus 17 squared plus 21 squared. Okay, plus 21 squared plus minus 58 squared. Okay, so that gives me 4094. And then I just take the square root of this number. My final answer will be 63.98 newtons to 2 decimal places. Okay, so that's my magnitude there. And then this is my vector, F2 plus F3. So now let's look at part F. So on part F, they're saying find the dot product. Okay, so we're finding the dot product of F1 with F2. So this will be equals to, okay, so F1 is 20 minus 3 and then 73. And then we're saying dot F2 is minus 17, 21, then minus 46. So when you're finding the dot product, you're just multiplying component wise. So it will be 20 multiplied by minus 17 plus minus 3 multiplied by 21 plus 73 multiplied by minus 46. So this will be equals to, okay, and then we multiply. So 20 multiplied by minus 17, I get minus 30. I get minus 340, sorry, and then minus 3 multiplied by 21 there. It gives me minus 63, and then 73 multiplied by minus 46, it gives me 3,358. So this, when I combine, it gives me a dot product of minus 3,000, okay, 761. Okay, so that's the dot product there. And we're done with the first part. We go to the next part, which is this question here. So this question, they're saying the dot products of a vector, let's say a vector V, okay, with the vectors, this one, and this one are respectively 4, 0, and 2. So that simply means that the dot product of this vector here, V, with this vector gives me 4. The dot product of this vector v with this one gives me 0. The dot product of this vector with this gives me 2. That's what they mean there. So I'm just going to say let v, okay, be an arbitrary vector. Okay, let's say xi plus yj plus zk. So we can also write this as x, y, and then z. So it's a vector that I have. Okay, so now this vector here, when I do a dot product with the vector v, I'm getting 4. So that simply means x, comma y, comma z dot, okay, when I write this vector here in this form, it will be 1 minus 1 and then 1. So this dot product, they're saying is equals to what? To 4. So I multiply throughout x multiplied by that, x multiplied by that, it will be minus y, the z with the 1 to be plus z is equals to 4. So this here is going to be my first equation. My second equation will be when I multiply this vector v with this second vector here. So that is 2, 1, and then minus 3. So this is equals to, we're told 0. So x multiplied by that, that gives you 2y. Y with the 1 gives you, in fact, what am I writing now? So this is x multiplied by the 2, that is 2x, and then y with the 1 plus y, z with the minus 3, I get minus 3z is equals to 0. So this here is my second equation. My third equation will be x comma y comma z multiplied by this vector here, which is just 1, 1, 1. Because the coefficient of all these are just ones. And we are told this is equals to 2. There. So it will be x multiplied by 1, just x plus y plus z is equals to 2. So this is my third equation. So I have a system of linear equations in 3 variables. Okay, so what method can I use to solve this? Okay, you can use any. You can use substitution, you can use elimination, you can use Cramer's rule. Yeah, any method can work here. So we are going to say, let's use the simplest. Okay, let's use the simplest. So the simplest is going to be substitution. Okay, the simplest is going to be substitution. So I'm going to say, here I have x is equals to, and then these guys should go the other side. So that will be 2 minus y minus z. Okay, then I'll get this x and substitute it into this equation and into that equation there. Okay, so I start with this one. When I replace the x there, what am I going to get? I'm going to simply get x. Oh, I'm replacing this x here with this. So that will be 2 minus y minus z. This has replaced the x. And then I have minus y plus z is equals to 4. So you see here that the z and the z will cancel out. So this will be 2 minus 2y is equals to 4. So meaning that I'm going to have minus 2y is equals to 4. Then this guy goes to the other side. That is minus 2. So that is minus 2y is equals to 2. Divide by 2. Divide this by 2. So y is going to be equals to what? In fact, I divide by minus 2 there. So y is going to be equals to minus 1. Okay, so we found the value of y. Y is just minus 1. So once we find the value of y, we can use it to find the value of what? The value of x and z. Okay, so in here, I'm going to say x is equals to 2 minus, the y is minus 1, and then minus z. So that will be x is equals to 2 plus 1 minus z. So x is equals to 3 minus z. Okay, so let's get this and substitute it there together with this guy. So that will be 2. The x is 3 minus z. Then the y is plus y, so that is plus minus 1, which is the y, then minus 3z, this is equals to 0. So here I'm going to get 6 minus 2z minus 1 minus 3z is equals to 0. Okay, so combine like terms together, what are we going to have? So combining like terms together, we have 6 minus 1 minus 5z is equals to 0. So meaning 5 minus 5z is equals to 0. So 5z is equals to 5. Divide by 5, divide by 5. That would mean z is equals to 1. Okay, so we found z is equals to 1 here. So finally now we can find our x. Okay, so let's find our x. So x will be equals to 3 minus the z is 1. So x is equals to 2. Okay, so it means here they're saying find the vector. So remember the vector was the xi plus yj plus zk, right? So this will just be equals to the x is the 2. So that will be 2i. The y is the minus 1. And this will be j, okay? And then plus the z is just 1. So that will be k. So this here is the vector, okay, that is going to give the respective dot products there. So try it out. So try to do a dot product of this and this. You're going to see you're going to find 4. If you do a dot product of this and this, you're going to find 0. If you do a dot product of this and this, you're going to find 2. So at your own time, just try it out. All right. So we move to the last question in this video, which is on orthogonal vectors. Okay, so we're still using the concept of the dot product. So let's take a look at this question here. So they're saying a vector A given by this, okay, and a vector B, okay. So they're saying if vector A is this and B is that, then find the value of lambda. So we can see the lambda is a part of this vector B here. Find the value of lambda for which A plus B and A minus B are orthogonal vectors. So when they say orthogonal vectors, it simply means their dot product is going to be equals to 0. That's what it means, orthogonal vectors. So meaning that because here they've said A plus B, okay, so meaning vector A, I'm assuming this is vector A plus B dot A vector minus B vector. This here is equals to 0. Why? Because they are saying they are orthogonal vectors. So if this and this are orthogonal, then their dot product is always going to be 0. So what we need to find is just the A plus B. So let's start with the A plus B. So A plus B, I'm just adding these vectors here, component wise. So this one here, if I get the coefficient there, it's 1 minus 1 and then 7. Then I'll say plus, this other one is 5 minus 1, and then that one is lambda. So when I add component wise, it will be 1 plus 5, I'll get 6, and then minus 1 plus minus 1, I'll get minus 2. Okay, and then 7 plus lambda, I get 7 plus lambda, like that. So here, this is my A plus B. Let's get my A minus B. Okay, or maybe I should do this. Okay, so I'll say, okay, so A plus B, found that it is 6 minus 2, 7 plus lambda, like that. So now let's find A minus B. So I'm just going to erase what I have there. Okay, so now I'm be dealing with the negative, so negative there. So 1 minus the 5, that will be minus 4, minus 1, okay, minus 1, so that will be 0. And then 7 minus lambda, that will be 7 minus lambda. So that one is our A minus B. So it's simply 4 minus 4, 0, 7 minus lambda. Okay, so now we know that we were told that these two vectors are orthogonal. So meaning that dot product is 0. So let's find the dot product of this. So that would be 6 minus 2, 7 plus lambda dot minus 4, 0, 7 minus lambda. So this here is going to give me 6 multiplied by minus 4. So that would be minus 24. Minus 2 multiplied by 0, that would be plus 0. And then this multiplied by this, what am I going to get? Okay, so that would just be, because this is just a difference of 2 squares. So it's going to give me plus 7 squared minus lambda squared. So whenever I have a squared minus b squared, this here is the same as a plus b multiplied by a minus b. So here I add 7 plus lambda and then 7 minus lambda. So you see it's following the pattern. So I'll just say 7 squared there minus lambda squared. But if you want, you can expand step by step. Okay, so now we're told this dot product here should be equals to 0. Okay, so meaning that what do we have? I have minus 24 and then 7 squared, that is plus 49 minus lambda squared is equals to 0. So this will just be, what is minus 24 plus 49? So 49 minus 24, that will be 25. So that will be 25 minus lambda squared is equals to 0. So lambda squared is equals to 25. We square root this side, square root that side, means lambda is going to be equals to plus or minus 5. Okay, so that's those are the values for lambda. Okay, it's either it's plus 5 or it's actually minus 5. All right, so thank you so much for watching this video. This has been Tutor Pro Solutions. Until next time, always there for you.